Alrighty, welcome everyone to day 20 of Advent Code. 10 seconds here to get started. These days have been getting a little bit hard, so the past few days I've had to stop after about 2 hours when it gets late and pick up the next day, so if it's a big cut like there has been, you guys know. But anyways, let's give this a shot, let's see what we get. It's finally time to meet up back with the elves. You try and contact them, however you get no reply, perhaps you're out of range. You know they're headed towards the groove where the star fruit grows, so if you can figure out where that is, you'll be able to meet back up with them. Fortunately, your device has a file, your puzzle input, that contains the grove's coordinates. Unfortunately, the file is encrypted, just in case the device were to fall in the wrong hands. Maybe you can decrypt it. When you were back at the camp, you have heard someone else talking about coordinate file encryption. The main operation involves encrypting is a file is called mixing. The encrypted file is a list of numbers. To mix the file, move each number forward or backward in the file. The number position is equal to the value of the number being moved. This list is circular, so moving a number off one end laps to the other. For example, to move 1 in a sequence like this, then the 1 moves in position forward. To move the -2 in a sequence like this, that moves the position backwards, wrapping around. The numbers should move in the order they originally appear in the encrypted file. Numbers moving around during the mixing process do not change the order in which the numbers are moved. Consider the following encrypted file. Okay, okay, this actually might not be too bad. Wow, those move a lot. Well, okay, it might not be too bad, but it might be a bit rough in terms of 5,000. Okay. Alright, so this is going to become a list of integer. This is going to become inputs. And let's just call it file, I guess. Whoops. Array list. So, not too hard to parse this, luckily today. This is an easy parse. So it comes down to the original file. And so because of that, I say we are going to, I doubt there's duplicates. I'm gonna assume there's no duplicates. So what we're gonna do then is we're going to do the call final, or not final, output, I guess we'll call it. And it's gonna hold file. We're gonna use file here just to know what number is next. So for int I equals 0 while I is less than file.size. Int num is going to equal file.get0. So figuring out its new index is not hard. You don't have to physically move it. We can calculate it by taking its index in output. So if we take its index, we know it needs to do is plus equals num. Actually, it's just index. But this isn't gonna work for negatives, right? Because if it wraps around a bunch of times, we're gonna be left with a negative number. And I believe this becomes not great when that happens. So how is this gonna work? Or how, so 1 moves between 2. So if it's, so we take it, so 0, we add 1, it becomes 1. So we remove it and put it, okay, so it's, yeah, remove. So what happens is we do output, remove, index, and then output, add num at index. I messed that up, my bad. That goes there. Oh, it's backwards. It's index number. This is gonna fail though for whatever. Okay, the Grove's coordinates can be found by looking at the 1000th and 2000th and 3000th number. Look at the after looking at numbers after the value 0, wrapping around the list as necessary. In the above example, the 1000th number after 0 is 4. Oh, okay. So index, so this is going to be 0 index is going to be equal to index of 0. So int is going to be 0 plus 1000. And then again, this lovely bit. 1000th, 2000th, and 3000th. Be found by looking. Another example is 4, -3. Adding these together produces 3. Okay, so we just add them together. So then we just do lap of output dot get 1000th plus 2 plus 3. So I think it's gonna fail. I'm gonna go to the test input because I'm pretty sure it's going to fail on the negative number. I'm gonna get -2, right? So it's failing, but because when we go to do this on num being -2, it's not correct. Oh, it would helpful if I got I, by the way, and not 0. Okay, so it's 1, 2, -3. So -3 should be moving to the left 3. Its current index is 1. So index, that's -2. And so -2 should ramp around to be 5. But it's at -2, right? So what I need to do well, if it's a negative number, this will still correctly do this, but it's just gonna be the negative. So what I can actually just do is I can do int new index is this. So I can do this, and then I can do it's a negative. I need to make it positive, so I can just add new index is less than 0. Add on file.size, otherwise add on 0, and I think that solves our problem. So I should get 3 as my answer. I get 4. I get 7. Okay. So index being 1, index being 2, one, 2, be -2 and 0. So this should be index 0, 1, 2, 3, 4. Index 5. Is a file size -1? Whoops. There we go. Okay. And let's try our input. Let's see what we get. 846. So close. Dang. I was hoping that would just work. Just verify, no, not this. Verify with the test input that I get the correct ending. Output -2, 1, oh. Negative, oh, wait a minute. I don't get the correct. Something's not right here. System out, print line. No, system out, print line, output. Can I output this? So that's correct. That's correct. 1, 2, 3. Yeah, that's correct. Good. Oh. -2. Is that 2? Oh. -2 should be if we get 0. Zero becomes the end. Okay. If index equals 0, index equals output dot size -1. Or no, we added the end. Does that give us the right thing? So get 3. But 4. 1, 2, -3, 0, 3, 4, -2. 0 doesn't move. One, 2, 3. The 4 is the last thing. Why is this 4 calculating weird? Oops, I just skipped right over it. We have it, we just don't have this last number, 4. So we get index of 4 is not 2. Oh, it was there. Oh, hold on. I need to go here then. I need to stop it early. I need to just follow this logic earlier. 4. So index is 5. 0, 1, 2, 3, 4, 5. That's right. Its new index is 9, which would be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. It gets removed from there. Oh. Do I need... Is it because because if new index is less than index, I need to add 1. Is that what's happening here? No, that's not what happens there. No. 04. 1, 2, 3, -2, -3, 4. Okay, so nope. I move this around. It's something to do with this. If I run this again. So index has been changed, right? So I should call this instead OG index. Remove OG index and put it there. Output size -1, right? Because I didn't do it. Four is still in the wrong spot. Why is 4 still in the wrong spot? It should be getting moved over 4. 1, 2, 3. So it goes to where it is, and then you insert it after that one. So it's technically you put it in the next index. So why do all of these work then? It's at 0, it goes to 1. It's because it's always before. So it's always before. So what I need to do this, I need to do is OG index greater than index. If it is, add 1, otherwise don't add anything. There we go. Please give me the correct answer. Oh, I just can output all of these. That was a bad mistake. Don't print them all out. Do this quicker. I get a negative number, which does not seem right, but I guess I could get a negative number. That's valid. No. Okay. Let's double check to make sure that these are all doing this correctly. 3, 3, 2, 4, 1, 3, 2, 0. Okay. Is there something about the reverse being true? Negative, yeah, yeah. 1, 2, 3, 4, yeah. 1, 2, 3, 0, 4, 2. 1, 2, 3, 4. 2. 1, 2, 3, 4. Oh, okay. -3 moves between negative... No, but I did it right. What am I missing? This is where it gets annoying. My example if it works, but mine doesn't. Oh, it's gonna put all the cases again. Put that there. Is that the issue? No, I still get 4, 9, 4, 4, 8. Okay. I did find my issue. My issue is if we have a negative number, so I change this a bit. This -2, if it goes up, if it tries to move up, it doesn't work. I think I need to do is otherwise, if OG index is less than index and number is less than 0, we need to subtract 1, otherwise do that. This shouldn't change. It shouldn't change this, should still get 3. Or not. Or not. Which one broke? Which one failed? It must be the wraparound. Must have been the wraparound. Initial 1, -3, 2, okay. 1, 2, 3. Okay, so it's the -3. It should be there. Oh wait, but that shouldn't have mattered. Is this wrong? The OG index. It's going left, so the OG index is still greater. Oh, never mind. This is the wrong logic. This should get moved to here. Let's keep this here. This does -1. Otherwise, this is 1 and 0. Okay, there we go. Now if I do my input, please work this time. Index 5000. It's trying to loop around. Index adjusted. That's not gonna fix it, right? That's just gonna break it more. I still got a negative number, but is it the right negative number? No. Okay, so it's broken by this is. Really? Oops, going too far again. Alright, eventually I will get this. Oh, yeah, okay, no, this doesn't, something broke again. How did I... Oh, that's not even right, though. What did I break? To the very first one. What the heck? Wait. Did I change how this worked? Oh, it was greater than. Did I change the wrong one? The OG index. Oh. I changed the wrong one. Is that all I did wrong? I do want this. Actually, you know what? YOLO. Give me my answer. Give me my answer, please. Still no. Oh, I didn't change it back to... give me my answer. 1, 2, -3, 4, 0. Yeah, okay, so they are working. Does it correctly handle the -2? 0, 1, 2, 3. It should be index 1. No. What? Now it doesn't want it. Oh. Is it because... Is it because this needs to be on here and number is greater than or equal to 0? I think it's gonna be greater than, but... Is that it? So we still get 3 with the correct ending. Okay. Give me a new number. I already had this as a guess, right? Wait another 3 minutes. Okay. I already had that one though. I'm missing something. Something is wrong. What is it? Okay, well, so I've been dumb error. I've been looking at this for like I don't know, it's been like almost an hour since I kind of stopped recording for a bit. It turns out that my assumption that all of the numbers were unique in the list is not true. And that is why I'm having so many issues. So, I need to redo this to support numbers. Or to support the fixed numbers. Yeah, good job me. So, we're going to need a private static class. This is going to be a num. What's called a num? And all it's going to hold is int number. Let's call it value, sure. Nice. And we can make a constructor, generate constructor. And the nice thing about default by Java is that we can just simply, actually I could probably just make it a string value, make this a little bit easier. Ensure parse int value. I can make this a little bit easier. And so let's become a number. New num. And what should happen is, besides everything breaking, this index of won't work, but that's fine. All that should happen is when I do this assert should say 5,000, 5,000. Nice. Okay. So, right. So now we get to this whole index of. You know what? I have been looking at other people's solutions to try and figure out why mine wasn't working, and comparing outputs and stuff. And a good idea I saw from what I was looking at was to actually have index on here. This might actually this index is the original index, so this is what we can do then to make a getter or a equals and hash code. That'll work for that. So now I can find, you know, new. Well, that's not gonna help me for finding that 0, but it will help me for this though. So this becomes inputs get I for int I equals 0, I is less than input dot size I plus plus. Fixes that, so now we can correctly get numbers. Index of that, right? So now it comes down to outputs. Oops. I'm just gonna stream this. I'm lazy. What's the there's no like find? Oh, because of filter. And dots, that's JavaScript. And dots value equals 0. It's JavaScript again. Find first, get index. Cool. All right, so this in theory should work. Please? No. Okay. Well, making progress. Making progress. Time to debug some more, but that was one of the big issues, so I wanted to record that bit. But now back to trying to figure out where my code is going wrong. All right, finally figured it out. We got our answer. The issue came down to, after refactoring, is that it's not simply adding or subtracting one, it's adding or subtracting the index divided by the file size, because if you wrap around more than once, you want to add more than once. You want to add how many times you wrap around, or subtract how many times you wrap around the negative way. The other issue was that stream stuff I did was not right. It was grabbing the index of the original index, not the index in the output. So I just did this quick, dirty solution here. We got it. Got our answer, 1087, and I already submitted it 1087. Finally, gotten it right. On to part 2. The Grove coordinate values seem nonsensical. While you ponder the mystery of alpha encryption, you suddenly remember that the rest of the decryption routine you overheard at the back at camp. First, you need to apply the decryption key. Multiply each number by the decryption key before you begin. This will produce an actual list of numbers to mix. Second, you need to mix the list of integers 10 times. The order in which the numbers are mixed does not change during the mixing. The numbers are still moved. Okay. So just apply the decryption key and just run this multiple times. So same thing. Okay, hold on. So this isn't actually that bad. I can just do this multiple times. Let me just save this. Private static final decrypt key. That's an int. Int. So we can just move this. So I'll just take. Sorry. Just take all of these, move this, public list number. This is gonna be not shuffle, but it's gonna be mix, I guess is what they call it, the term for a mix. List number file, and then return outputs. Is this one also 0? Okay, so it's the same thing. So I'm also gonna make a public int get value or get answer. List a number, sorry. Because I am lazy. Alright, and I'm not lazy, but I just want to make this a little bit more condensed. This goes all in there too. Make this a bit better. Okay. So now we just do list num output equals mix file get answer for output. There we go. Num. Oh, num, not number. Okay. So now we get to part 2. And this is where I think we need to change number to be a long. Whoops, not that. Change value to be a long, so we're multiply each number by the decryption. Yeah. These need to be longs. Ooh, is that even gonna work? If it is greater than max equals this, let's just do num. Max, and then max times. Pretty sure that's going to be an issue. Yeah, that's only okay. That's the max. Okay, so it's not too bad. So can this handle a long then? Change value to be a long. Yeah, that's fine. Longs. All gets adjusted. Let's use return a long. Okay, so if I make everything a long, is it? It is, okay, it's within it. Good. So that's all I need to know. Actually, I should do min just to be safe. Just to be safe, that min is also, if it's the same. Okay, we're good. Just want to make sure. Wanted to make sure. Okay. So now we can use a long, so we just need to well, I is less than 10, I plus plus. I just call it a new array list, give it file. And then we're just gonna run this 10 times and then output that, but we can't forget to go for num. I should have left that num in here. And file num dot value multiplied equals the decrypt key. And now if we run this, it should take less than a second. Oh. Hello. Excuse me? Excuse me? Oh, it does it so much it wraps around again. I have to do this. Long. I think it's just this, but instead of that, it's that. Long wrap. Wrap. If it's less, so that's how much it's wrapping around, but it's wrapping around too many times. It's why it's going out of bounds. So we want is, so there's our wrap, and then only because we want to do wrap file.size, but that's not gonna work. It's less than 0. That's fine. No, I think it's just this. We'll see. I see. I see. I see. Okay. I say, what if I... Okay, so I got 1087. So what if we just save the wrapping of the index for the very end? So here's the index. I'll leave that one alone. So it's just this, all we care about. So forget wrap count. Well, keep wrap count, put wrap count there. So now it's on here. So here's our index adjusted. So now we need a long final index. That's to be index adjusted, and that's making sure that it gets wrapped correctly. Which honestly is probably just this. Or instead of new index, it's index adjusted. That's not right. My number is, I believe it's a positive number. I mean, it could be negative, I guess. No. More debugging time. Fun. Okay, I've been working on this for a bit, and I found a critical bug. I worked around it in part 1. That whole mess of if logic to like add and subtract 1 or 2 depending upon the wraparound, that was only needed because I was always using the file size to do the remainders and the calculations. I should have always been basing my logic off of the output, which was being changed by, you know, the remove and the add. And so because of that, that's why I do all that fancy logic. But if I do it correctly and I use the size here, I can simply just use basic logic of, you know, getting the index just being the original index plus the value, do a remainder upon however many is left in output after removing it. And then if the index is less than 0, simply just adding on the output size. And that'll allow me to correctly input it in the correct spot. Oh my goodness, I should have just been using the right value from the start. So that fixes part 1 much better. All that's left now is part 2. Part 2 is almost working. For some reason, I get the first one working, but now I'm on the second one. The second one doesn't work. So now I'm just trying to get the 10 mixes to correctly work. For some reason, after the first one works, the second one works, but then the third doesn't. Something's going weird there, but I'm getting closer. I'm getting closer. Almost there. All right, I believe I finally figured out. It was the fact that this for loop always needed the original number file to go off of. It always went off of the original mixing, the original file you mixed. You didn't mix I was passing it. Yeah, okay. I understand, but I'm struggling to explain it. But fix that. I've got a new answer. I'm just praying. I'm hoping that this is right, and I'm just going to submit it. Finally, we got it. We got it. Okay. Both parts are done. That one, I did so many bad mistakes. That one was not hard. I just made terrible mistakes that cost me a lot. Explanation time though. So, for this one, we are given a list of numbers, and they get moved around according to the rules it gives, the question gives you, to kind of decrypt the numbers into some sort of message. I'm assuming that might be a feature today, but we'll see. To do this, first thing is we just go through line by line of our inputs. We convert this to I have a num here. What this num is, it's the value that's at that line, but we also add the index that that value is in the original input. That way, because as I found out and I made the wrong assumption, there are duplicate numbers in our inputs. Not the example, but in the input there are duplicate numbers, so we can't just use integers. We have to have some sort of key with the integers to know which one is which from the original file. And I guess coming from a TurkeyDev stuff, using index as your key for things is a very cheap way to do it. That should be done, but it does work. So that's why we have index here, is again just to use for the number to be able to relate it back to where it was in the original inputs. And then from there we go and we do the mixing, which is the actual logic of the rules it has you do. It's simply just going through all of the numbers in the original or in our input. This OG file is our input, so all this is OG file. Going through all of those in the order they were in the original file. We have to go through. We have to find it. We have to find the index of it in our output now. This is why having the index is crucial, because if you have two numbers, there's no way to know which one was which relative to this file. So if you have the index attached to it, you know which one was which because you just find the number that was at the original index, which is why we have that, and that's why this equals and hash use it. So we find that number here, we remove it from our outputs. We then find the index where it should be, which is simply just taking its original index, adding on its value, and then modulus of the output size. That will just simply move it to where it needs to go. If it's a negative number, we're going to get a negative modulus value, so our index is going to be a negative number. Java doesn't support that for add, but it's a simple fix. You just take the index it's going to be, so the negative number, and add on the size of the array, and that will give you the correct index as if it were a negative. And they simply add it. My whole thing for part one that I had all that extra math you saw me had was just because I was using the OG file size here instead of the output file. I should have been referencing everything in terms of the adjusted file that I already had the value removed. That was a big problem for me. It gets much simpler if you always use that file. And you just do that for the full length of the input file, and that is it. That gives you the mixed file. And then you just get the answer. The answer is simply just finding where the 0 is. I could have made this a little bit easier, like storing like the 0 when I found it up here, but it's fine. Just find the 0 index, then add 1,000, 2,000, 3,000 to that index. Get the values there. Again, making sure you modulus it. That way it wraps around. And then you return that, and that's your answer. Part two, the only thing that changes is now there's a decrypt key, which just multiplies itself onto every value. Just take every value in this. Ooh, don't move anything around. Just take every value in here, multiply it by the decrypt key, and then do the exact same thing over again, making sure you call mix 10 times because that's what it asked for, and then just do an output. It's simple as that. If you don't make the dumb mistakes that I did, you'll do this much quicker than me. It is late, so I need to quickly edit this and get this out for you guys, but that is day 20 complete. See you guys tomorrow for day 21. Peace out.